Dota, Go and poker, AIs have mastered the skills of teamwork, strategy and bluffing. But in Trackmania, AIs have been unable to play at any decent level for the last 15 years. Until now. I've spent the last 2 years training an AI that plays Trackmania. It's time to put it to the test. Can my AI rediscover the advanced techniques that humans use to shave hundredths of their time? I'm going to challenge it to beat as many world records as possible on the official Trackmania campaign. Welcome to my biggest story yet. The story of the strongest Trackmania AI ever made. Before we get to the main challenge, let's take a look back at the AI's progress over the last year. The AI had reached a respectable time on a flat training track. It had mastered drifts and trajectories in general. I asked around for good players to try and beat it, and the streamer Virtual took the challenge.
How hard could it be? Because the AIs that I've seen play Trackmania have all been pretty bad.
He quickly found out that this AI wasn't like the other ones.
Jesus! Oh, it's 5 seconds still.
But eventually, with a bit of practice, he was stronger.
Woo! Humanity! We win! It took me 53 minutes, but I beat the AI.
The first version of my AI was defeated, but at least I now knew why.
Holy... It would literally beat me if it wasn't for neo-sliding. And it still knows how to do them, but it like doesn't do them optimally.
Eventually I came back with an improved version. It beat version 1, and not long after it was able to beat Virtual. And there was no sign of stopping, it just kept improving. Until it was more than 2 full seconds faster. When he saw this, Virtual had to react.
The AI knows how to neo-slide, which is not at all terrifying.
He tried for some time, but he was never able to gain the upper hand.
I am offering $100 to the first person that can beat the 202.48 by the AI. Send our best soldiers to battle with this thing. We are not going down.
The player Lozo managed to beat the AI with precise driving skills and a trick of his own. He did not slow down to take the inside line, but instead went full speed, slammed into the wall and kept a lot of momentum. This trick is called a wall bang, and with it, humanity beats the machines again. The thing is, it's going to be very hard for the AI to find wall bangs. This problem is called a local optimum. Yes, the wall bang is better, but you really have to commit to get a good bounce. And since the AI learns through gradient descent and small exploratory moves, it would take impossible luck to discover it. I showed you version 1 of my AI, which had basic racing skills but still enough to challenge a good human player. And I showed you version 2, which was all around better and possessed the skill to neo-slide. Stay with me as I progressively unveil the major improvements that will be made by version 3. Wall bangs are so difficult that I actually gave up and decided to work on another track. I picked AO1 Race, the first official map. It's composed of 3 main sections: the downhill, the speed slide and the uphill. In the downhill, good players release the gas to reduce airtime and maximize their acceleration. A speed slide is a technique to gain even more speed, but it requires precise inputs to exploit a bug in the game engine. In the uphill, players abruptly steer right to get better grip and more speed towards the big jump. I quickly noticed the AI had a lot of trouble in the third section with the big jump. I dumped the memory buffer and found out that it focused way too much on risky events like landings. This made it unable to learn the simpler lines of the map. Basically, it was blinded by the more difficult zones. So I implemented something to spread the AI's focus on all parts of the track evenly. This immediately gave massive improvements, so much that I went back and applied the same technique on the previous training track. Now, let's train the AI together. First, I need to set up virtual checkpoints to measure the AI's progress along the track. Then I can start the training script. The AI has to learn everything from scratch. It's a process of trial and error in which every car you see on the screen is controlled by a slightly different neural network. It's not very good yet, but it's going to improve. While it's training, I'll show you what it's like to play as if you were the AI. It only sees its surroundings through grayscale screenshots, scaled down to low resolution and low refresh rate, as well as a few information taken from the game engine. Do you think you could play well in these conditions? During training, it quickly caught up to version 1, then virtual. It wasn't even close to being finished. With a bit more training, it overtook version 2, and at that point, it was head-to-head with Loso. And it just kept improving until it found the wallbang. Honestly, I don't know how it's possible. I thought it was a fluke, so I retrained from scratch, but it found the wallbang again. I don't think these replays really convey how much stronger version 3 is against all other benchmarks. It's really in a league of its own. The training graphs are really the best way to show how much faster this new version learns, and that it learns much better trajectories. The AI is comfortably 1.5 seconds ahead of the best human time. Surely, that's not within reach of humans anymore, right? It's fair to say that version 3 is an all-around improvement on version 2, but I still haven't revealed all of its new abilities. Stay with me to find out. We're just getting started. What about the other challenges Trackmania has to offer? Nadeo released 65 official maps in 2008. They feature gravity-defying jumps, precision wall rides, and tricky dirt sections. Each one brings a unique test of skill. This is where players gather to compete. This is where champions are made. This is my next target. Can the AI rise to the challenge and beat human records? But it can't handle cuts yet, so I'll only look at comparable human runs. The problem is, it takes forever to train the AI. Running the code from scratch takes days, and there are 65 official maps, but I think I can make the code faster. At the moment, my code can play, then learn. Play, learn. It can't do both at the same time. So I rewrote the code with multi-processing so that both can happen in parallel, and I made sure the AI could play multiple games at once. With this, the AI's training speed has tripled. Big thanks to Kim and Donadigo from the TMInterface team for making this possible. We'll start with AO2 Race. It's a short but deceptively complex track, broken down in 3 sections: the start, the wiggles, and the jump. In the start, players must take a sharp turn but want to avoid drifting as it tends to lose speed. The second section begins as soon as the car hits 4th gear. Above that speed, it becomes beneficial to perform gentle wiggles. With that trick, the player Racehands took the record in 2011. Then comes a large jump that players used to take in a straight line. It took 9 years for players to realize that it was possible to jump diagonally and land on the barrier to accelerate faster towards the finish. With this, the player Roland took the record in 2017. All these lines were perfected by thousands of players to achieve this run. The player Alien holds the current no-cut record since 2018. Now, it's time to train the AI. Let's look at the AI's run from the point of view of the best human run. Amazingly, the AI beats Alien's time. It found the diagonal jump, the dirt wiggles, and had a perfect start through all the bumps. With just a few days of training, the AI was able to rediscover most of what human players had found over a decade. But actually, with the latest version, the AI found an even better start, and simply jumping left to right is able to get this run. It finished 1/10 ahead of the best no-cut human run. Let's switch to DO6 Obstacle. This map is a really interesting challenge. All you have to do is ride round and round on the wall for 3 laps. But as you gather speed, the car becomes much more difficult to control. There are 2 routes on this track. The normal one, with a strong record set by Darkbringer in 2018. He follows the intended path, going up and down along the wall with tight lines. And for a decade, everybody thought this was the only route. But then in 2021, it was discovered that once you've gathered enough speed, on the second and third laps, you can completely bypass part of the track by jumping from one corner directly to the other to avoid losing speed from steering or releasing. With this shortcut, the player Roland gained more than 1.5 seconds over the previous record. Now, let's train the AI. Let's look at the AI's best run. I also put on screen multiple copies of Darkbringer's car. I hope it makes it easier to understand where the AI gains time. Already 1 lap and it's still close. Darkbringer now needs to lift off the gas to maintain control, but the AI doesn't release and gathers more speed with wider lines. It's not even close. In a game where improvements are measured in hundredths of a second, the AI crushed Darkbringer's record by 1.65 seconds. But actually, how does the AI compare to the shortcut record? The first lap is uneventful, we'll just fast forward. In the second lap, Roland skips the turn with the cut, but the AI doesn't release and is able to gain the advantage on the ground, going into lap 3 with a half a second lead. In the third lap, Roland uses the shortcut again while the AI stays on the intended path. When the cars rejoin after the shortcut, Roland is still behind, but his superior speed lets him overtake the AI. He is a car's length ahead going into the last turn, until... The AI has won on the training track, AO2 and DO6. Let's continue with other tracks now. The AI has beaten almost every human record it has faced. This is incredible. If it keeps getting better, we'll have to compare it to TAS runs. You see, in Trackmania there are two types of runs: real-time attack and tool-assisted, or TAS. In a TAS, players use tools to optimize their runs by slowing down the game, brute forcing small segments and splicing them together. This results in crazy runs which often look nothing like how the game is meant to be played. My AI falls somewhere between a human and a TAS run. Like a TAS, it has direct access to the game engine. But I believe it's closer to a human run, because it has some understanding of what it is doing. It can adapt during runs, like human drivers react to slight mistakes. This ability is what makes the AI truly unique. In fact, I can show you. Even after making big mistakes in this run, the AI manages to recover and finish. Beyond the official maps, Trackmania has over 600,000 tracks made by the community. In my previous video, you guys suggested some crazy difficult maps like Final Enigma. This is a trial map in which the first objective is just to finish the map, because it's already really difficult just to get to the end. This is a good challenge, but I want to start with one of the easiest maps in this category. It's called Minitrial. This is a 1 minute long map, but I'm mostly interested in two specific sections, here and here. The first section has a narrow bridge followed by a jump. You might want to take it safe, but then you would miss the speed check and not make the jump. The second is a trap where the road appears to go left, but the car must instead fit in a narrow opening below towards the next platform. I'm going to train the AI on this map without any modification. The jump is not a problem, we've already seen the AI can be very fast. The second section proves to be more difficult, the AI can't find the narrow passage. Remember these checkpoints I used to measure the AI's progress? The problem is, both of the cars you see on screen are progressing at the same speed, but one is on the correct path and the other isn't. I need to give the AI an additional reward for being close to the red line. Let's retrain with this new reward. Okay, this is definitely not what I expected, but this is AI for you. It will always find the dumbest way possible to fail the task. It's braking before the jump. It took me some time to figure it out, but I think I know what's happening. You see, the AI has two options to maximize its reward. Either try to make the jump, or wait near the ledge. If it tries to make the jump, it first receives a small amount of reward for advancing and a large punishment later for getting too far from the red line. If it waits near the ledge, there is neither a reward nor a punishment. It's probable that I've made the punishment so strong that the AI is not willing to risk the jump anymore. The thing is, there is a parameter called gamma in reinforcement learning. It controls whether the AI prefers immediate rewards over later rewards. I won't detail it in this video, but I have put a lot of work into making sure my AI is balanced and can work with gamma equals 1. I will set a gamma slightly below 1 so that the AI is short-sighted and prefers immediate rewards. With these changes, the AI finds a solution for the jump and for the narrow passage, and 1 hour later, it was able to finish the map. Let's see what the AI has learned. There are 10 cars on screen, they are 10 copies of the same world record run with a nearly 2-second head start. This will help us judge the AI's speed. The overall trajectory is well optimized and the AI even finds a wall bang. Halfway through the map, the AI is already more than 1 second ahead of the world record. It has learned to use wheel clips for faster 90 degrees turn. At this point, the world record uses a shortcut and the AI stays on the intended path. 8 seconds later, the cars rejoin and the AI has lost some ground, but its higher speed lets it finish 1.8 seconds ahead of the world record. Looking back at this table, I think it's fair to say that the AI has proved to be pretty good on all kinds of standard maps. And I also give it a few points for beating a trial map, but most trial maps are usually much harder than what the AI has done. Now, I'll explain some of the inner workings of the AI while we watch it race against humans. My code is basically a heavily modified version of the IQN paper. This is an algorithm that works well in environments where there is uncertainty. I've chosen it because sometimes the game can feel random. When driving close to the limit, it's sometimes a toss-up that decides whether the car hits the wall or not. Over the course of the video, I've mentioned 2 important improvements I've made. Removing any of them makes the AI much worse. But for a more technical breakdown, I'll have to address them another time. All of this is done on a mid-range gaming computer. The only special thing about it is that I have 64 GB of RAM because I need to store 1 million screenshots in memory. There is a lot of talk these days about large language models having billions of parameters, but we're really quite far from that. The neural network I use is not much bigger than a fruit fly's brain. Now, where do I go from here? Some of you suggested that I train a more general AI that would be able to drive on multiple maps. This would help reduce the computational effort of training many different versions of the same AI. I've made a first attempt, and I have to say it's quite promising. Have a look at this replay. The racing lines are not really optimized because this is a map the AI has never been trained on. It's as if you were playing this map for the first time. I feel it's already quite an achievement that the AI is generally able to obtain bronze and even sometimes silver or gold medals on maps that it has never seen during training. There is a map that is well known in the Trackmania community. It's called Deep Fear. I'm told it's so incredibly difficult that it took 5 years for even a single player to finish it. Rastats made an interesting promise in the comments of my last video. I'd hate to disappoint, so I feel I have to try this map soon. There are quite a few maps and shortcuts that the AI can't tackle yet. I'm not sure the AI will ever be able to find original shortcuts alone. Some human guidance may always be necessary to produce the best times. Some of you already expressed interest in helping develop this AI. We plan to open source the code in the coming months and will welcome contributions. Who knows how strong this AI could get when the whole community gets involved. For this video, I have not used any kind of look-ahead algorithm like beam search or MCTS that would let the AI plan its route ahead of time. These techniques are pretty easy to wrap around my code, and I'm pretty sure they'd significantly improve performance. This is AO7, a tech map that demands pixel-perfect precision. On this track, the human record is within 1/10 of the theoretical perfect run. The AI is barely able to equal the human record. It's a testament to the incredible patience, skill, and passion of top players that they have achieved such mastery. I want to conclude with the last map that has a special meaning to me. It is one of the first tracks I trained the AI on. It has been a regular benchmark to measure my progress. It is one if not the most prestigious track in the game. I published a video in September showing my AI was 23rd in the world on that track. ESL Hockolicious is the map to showcase my AI's progress.